Algebra 2 at trig, 8B.4a. We're going to evaluate trig functions. We'll talk about quadrantal angles again, but we're definitely referring to reference angles. Here we're going to deal with a circle, not necessarily the unit circle. We have an xy, which is a point on the circle. If we were going to calculate for these values, we would want to draw a triangle. And we can perform Pythagorean theorem with that. And so that's always going to be your y value over the radius. That would be the opposite over the hypotenuse. The hypotenuse is always going to be the radius, and the y value is always going to be the opposite side. Cosine is going to be the adjacent over the hypotenuse, which your adjacent side would always be x. Your hypotenuse is always the radius. Tangent would be y over x, the opposite over adjacent. And then when we come over to talk about our other three trig functions, cosecant is the reciprocal of sine, so it's r over y. Secant is r over x. And cotangent is going to be the reciprocal of tangent, so it's x over y. We could also call these circular functions. Topics that we've talked about on the unit circle before is that the equation that represents a unit circle is x squared plus y squared equals 1. That means the center is at 0, 0, and the radius is 1. You take the square root of your r squared, which gives you still 1. Yes, and these are circular functions. We've talked about quadrantal angles before. Those are the angles that are right on the x-axis and y-axis. Those will always be multiples of 90 degrees or multiple of pi over 2. You can get to your next quadrantal angle by 90, 180, 270. We're adding 90 every time. There are multiples of it, so 90 times 2, 90 times 3. You can do the same thing with pi over 2. Pi over 2 times 3 would be 3 pi over 2, and that's coming down the negative y-axis. Here we're going to have the unit circle. We're going to evaluate the 6 trig functions for when theta is 2 pi. So I like the geometry aspect of it, so I would encourage you to draw your circle. We're talking about the angle that goes all the way around, and it comes right back and points down the positive x-axis. That coordinate there has 1 for x because it's 1 to the right, and it's up and down nothing, so it's 0 for the y. The sine of this 2 pi, remember your coordinates are always cosine sine. So your sine is 0. The cosine of 2 pi is going to be your x value, which is 1. And the tangent of 2 pi would be your y value over your x value. In this case, it's 0 over 1, which is simply 0. Now for our other 3 trig functions, cosecant is the reciprocal of sine. Now, how do we do the reciprocal of 0? Well, this is 0, and whenever you have a number, 0 over 1, you would have that number over 1. So you could consider this 1 over 0, and you know you cannot divide by 0, so this would be undefined, and we abbreviate that UND. Secant of 2 pi is the reciprocal of cosine. Cosine is 1, so that's 1 over 1, so it's still 1 over 1. And then we finish up with cotangent. That's the reciprocal. So it becomes 1 over 0, and you can't divide by 0, so we call that undefined. Now, if we were to do that with 270, we would do the same thing. But now we're coming down for the negative y values, 270 degrees. We know that coordinate is 0 for x, 0 right and left, and negative 1 for the y. So we know that the sine of 270 equals negative 1. The cosine is going to equal 0. And the tangent is going to be the y over the x, which is undefined. The cosecant is the reciprocal. It's still negative 1. This would be 1 over 0, so that's undefined, reciprocal of cosine. And cotangent is the reciprocal, so it's 0 over negative 1, which is just 0. On the flip side, we're going to talk about a reference angle. And a reference angle is the angle to the x-axis. Let theta be an angle in standard position. The reference angle for theta will be an acute. Notice that. It will be an acute angle. We can call it theta prime, formed by the terminal side and the x-axis. So if we have an angle pointing off, where this would be considered your theta. Your theta prime is the angle whatever it takes to complete 180. So if you're in the second quadrant, you had a number like 120 degrees, you would take 180 and you would subtract your theta. I don't like these formulas. We'll talk more about it as we do them. But if you're a formula person, you're taking 180, which is the angle to the x-axis. All right, you could also call it pi if you were in a radian format. So either format. And that will give you your reference angle. Same idea here. If you're in the third quadrant, you've gone past 180 already, so you're larger than 180. So you're going to take your... Okay, I'm sorry. Back here, I put primes on those, but those shouldn't be primes. Those are the values we're looking for would have the prime. So over here, we would take your angle that they give you, and you would be subtracting 180. Again, not my favorite way to handle it. It would be your angle minus pi would give you your new reference angle. And here we would take 360 minus the angle they give you. That would give you your reference angle. It might seem a little arbitrary at the moment, but we can do this. So, for some helpful hints, what you want to find is to graph out theta. So we graph theta. Then we are going to identify the angle to the x-axis. And thirdly, the reference angle is always positive. So let's try this. We're going to graph out approximately where 7 pi over 12 is. We're all becoming familiar with the unit circle, and you might realize that 7 pi over 12 is not on the unit circle. So 12 over 12 would be a full pi. That's what it would take to come over to what you might call the 180. That's a full pi. Half a pi is going to be 6 pi over 12. So 7 pi over 12 will be a bit past 6 pi over 12, which is half a pi. So that's your theta. Now we're looking for this reference angle, and that's the angle that's formed right here. When we do further calculations in the future, we want to know what this angle is. It's tough to make a triangle using 7 pi over 12, but it's a lot easier to make the triangle using the reference angle. So if you're at 7 pi over 12, how many more of those radian steps do you need to take to get to 12 over 12? You would have 5 pi over 12. I feel that you can do that without the formulas. If you're in a radian, you want the answers in radian. Notice we did not do any converting. We did not use a calculator. You could say 12 pi over 12 minus 7 pi over 12 gives you 5 pi over 12. But I feel that you should be able to identify if you're at 7, you need 5 more to get up to 12. All right, let's try negative 295. Negative 295 is going to be more than negative 270. So there is your negative 295. How many more degrees do you need to go to get to the x-axis? If this was 300, it would be 60 more degrees. So since it's 295, it's going to be 65 degrees. 65 degrees is your reference angle. That would be 360 minus your 295 is going to give you the 65 degrees. Because you're measuring to the 360 marker, that would be a way to think about it. Now 210, you might be familiar that that is a value on the unit circle. 210 is on your unit circle. We still want this angle that is right here. How many degrees past the x-axis have we gone? So if you take your 210 and subtract what it takes to get there, that gives you 30. Mentally, you can realize that 210 is 30 degrees past it, so it's a 30-degree reference angle. You don't have to use these formulas. I'm not a fan of the formulas, but they're there to support us if you are. Negative 7 pi over 9. Now that is not a unit circle value, so we have to think a little bit. Negative direction, we're going down. We know that 9 pi over 9 would be all the way over, so this is 7 pi over 9. Half of that might be 4.5 pi over 9. So we know that 7 is going to be off in this direction. What is your reference angle? What is that angle value to the x-axis? How many more do you need if this is negative 7 pi over 9? How many more degrees do we need, not degrees, this is a radian, to get to our x-axis? That's going to be 2 pi over 9. And remember, it's always going to be a positive value. And then you have two more that you can work on. Negative 260 will be in that direction. You want your reference angle that it takes to come back. You know that that's going to be 80 degrees. 90 degrees would be all the way to the x-axis, which is 270. And 15 pi over 4 that's 16 back to it, so 15 pi over 4 is over there. So your reference angle is pi over 4.